Hello, my name is Warren Maruziak. I'm a technical evangelist here at Atlassian. And today I'm going to be talking to you about CI/CD and Bitbucket pipelines in particular. We're going to do kind of two things in this video. We're going to take a look at how to set up a Bitbucket repository to have CI/CD. We're going to take a look at the structure of Bitbucket pipelines.yaml file. The example we'll be looking at is how to deploy a simple Lambda to AWS Lambda using Bitbucket pipelines. We'll dive into that, take a look at it, how to structure your CI/CD pipelines, and talk about some of the value that teams get out of it. The other thing we're going to talk about is CI/CD in general, and just why a team might want to use CI/CD and what value CI/CD kind of provides. So to start with, we're going to dive into kind of the demo portion, and then we'll move into the general discussion about CI/CD later. So on my screen right now, there's a repository in Bitbucket called CPP test. This is a simple C++ application that is meant to run in AWS Lambda. So what we're going to do is we're going to enable pipelines. Now I've already got all this worked out, so we'll just take a look at how we would do that. To turn pipelines on in an empty repository, we're going to go to repository settings and click into here, and then we're going to scroll down, and there's this pipeline section that you can see on the left. If you click into settings here, this screen is going to come up, and there's this little green arrow. So this is going to be off by default. If you check this, that enables Bitbucket pipelines. So from there, if you build a pipeline file in your code repository, when you push to Bitbucket, Bitbucket will pick that file up and run a pipeline based on whatever you have in there. There's a bunch more configuration that you can do. We're going to dive into this in a little bit, but I want to go back to the code and start taking a look at how we build out a Bitbucket pipeline.yaml file. So the first thing we would want to do, if we're going to start working on this, we would click our clone URL and grab the clone URL, and then we're going to clone that down to our workstation with Git. So I've already got that done. And this is Git status, Git branch. My CPP test 01 repository. Now I'll take you on a quick tour of this, and we'll talk about some of the files in here. So to start with, if we take a look at source, there is a single file in there, which is main.cpp. And this file is very uninteresting. Basically, it sets up a Lambda invocation handler, and all this thing does is return the word cake when you invoke it. Nothing fancy here. So the simplest, most basic example of a Lambda. And the other thing we're going to look at is this Bitbucket pipelines.yaml file. This is the file that developers need to author when they want to create a Bitbucket pipeline to deploy their code to whatever environment they want to deploy to. So Bitbucket pipelines are very flexible, and you can do a lot of cool stuff with them. You can set up pipelines to kind of run whatever set of steps you want. The real basic structure of most pipelines involves building your application. So this is going to be like doing a compilation step. Once we've got a compilation step completed, we're going to have some artifacts that we can deploy. Once we've got those artifacts, we're going to deploy them to whatever running environment we want to. So in our case, the execution environment for this piece of code is going to be AWS Lambda. But if you were using on-prem servers or say AWS EC2 or some kind of GCP stuff, all of that is possible. Because what you can do is write scripts to do the actual deployment steps, and then have Bitbucket execute those steps with the appropriate parameters for you. And you can order those however you want. And you can also add testing steps. So after you've built your code and you've deployed it, you're often going to run a set of tests to see if the deployment has broken anything. So that's also possible. Very flexible in what you can do in a CI/CD pipeline. So let's take a look at this particular Bitbucket pipeline. At the top, these first 4 lines here use the image tag, and this is telling us to use a Docker image for all of the steps in this particular Bitbucket pipeline.yaml file. So Docker makes a really nice build environment. You don't have to do this. This is an option. By default, Bitbucket pipeline steps run on a Docker container provided by Atlassian. But if you have custom requirements for your steps to execute, say you need specific tools installed to build your code or run tests against your code or do anything else, you can create your own Docker images. In this case, I'm using a Docker image for every step. You can also specify specific Docker images for each step in a pipeline. So if you had a step that required different tools, it'd be very easy to set up multiple Docker images and use those different Docker images and different steps. So all we needed to do here is provide kind of the URL for the Docker image and some credentials to pull it down. The password is passed in as a token, and that's handled by Bitbucket Pipelines. So Bitbucket Pipelines gives you secret management out of the box. You can set secrets on the repository level, and then those repository or secrets are specific to the repository that they're in. You can also set secrets on a project level. So if you want to have every repository in a particular project have access to those secrets, you can do that. So there's some flexibility there. Now, the next thing we have is a set of definitions for steps. These steps are reusable. You can call these multiple times if you want, but basically underneath definitions and steps, you would define each of the steps that your pipeline would have to do. No, this is not an ordering of steps. This is just defining the actual steps. Think about it like writing a function, or sorry, a class in a programming language. And these are the various functions that class provides. You're not invoking them in a particular order to do something. You're just defining the specific functions. So the build step here basically builds the application, and it goes through the simple steps necessary to do that. So for this application to do the build, you've got to run makedir to create a build directory. You've got to change directory into it. You have to run cmake to invoke the cmake list file, and then you're going to make, and you have to call this thing make AWS Lambda package btest01. That just bundles this up into an executable or into a zip file that you can then deploy. And when we're done, we have this artifact section, which you can use to specify output artifacts of this step. So artifacts are shareable between steps. So once the build step is done, we've done a script that has compiled our C++ application into something that Lambda can understand. And we've bundled it up into a zip file, and we're sharing that bundled zip file with the rest of the steps in this pipeline. We can then define a step to do a deployment. This deployment step basically exports a couple credentials to the environment, AWS access key and AWS secret access key. It's required to hit the AWS command line. If you're not using AWS, these wouldn't be here. You would specify your own credentials. And then I'm invoking a deployment script. Now, this deployment script is responsible for creating all of the things necessary for this AWS Lambda. It's a bash script, and it takes a single parameter, which is the AWS region we're deploying to. We'll take a look at this script in a little bit. But basically, we can author a reusable script here that does the actual AWS CLI work to do the deployment, and then just share it over and over again. I have 3 deployment functions. Each of those steps deploys to a different AWS region. So we define a deploy to test, which deploys to our test environment. We define a deploy to staging, which deploys to our staging environment. And we have a deploy to production, which deploys to a production environment. You can have as many deployment steps as you want. It really depends on the set of environments that your software runs in. So if you have a very simple setup where you have 2 environments, test and production, you can do that. If you have a more complicated environment where you have multiple test environments and multiple staging environments and then multiple production environments, you can also do that. It's very flexible here. In this case, I'm demonstrating a test and staging environment and then a production environment. Now, the other thing I've defined are some test steps. I've got a test step for running integration tests in the test environment. And basically this invokes the Lambda after deployment. And I have similar steps for staging and production. So you can define kind of whatever you want in these steps. If you want to deploy, if you want to invoke linters, if you want to execute tests, if you want to look at metrics, there's all kinds of stuff you can do in here. It's really up to you what you want to do. Now, once you've defined all the set of steps that are important to you, you actually define the pipelines. So that happens under this pipelines command. So the default keyword is basically the pipeline that's going to execute whenever you push to any branch that's not handled somewhere else. So if we look down a little farther, I've got branches and mainline. This pipeline is specific to when we merge or push into the mainline branch. Mainline is our production branch. So if you push into a feature branch, a non-mainline branch, you're going to execute the pipeline under default, which has 5 steps. First thing it does, it's going to build the application. Then it's going to deploy to the test environment. Then it's going to run the tests in the test environment. If the test pass, it'll then deploy to the staging environment and then run the tests in the staging environment. So whenever you commit from your workstation and push to Bitbucket, with Bitbucket Pipelines enabled and this Bitbucket pipeline file in the repository, you're going to invoke this pipeline, which builds and deploys to 2 regions and also run tests in 2 regions. The idea here is that if this pipeline runs to completion and there's no errors in the pipeline, you successfully deployed to your test and staging environments, and that all of the tests you've decided to run against those two environments have passed successfully. At this point, you would probably cut a pull request to merge your feature branch into mainline. And when that happens, you would execute the mainline branch. And the mainline branch is a little bit different. It still does a build step to get our artifact that we need to deploy, but then it deploys to the production environment by using the deploy production step. And then it runs the production tests to make sure that the deployment to production hasn't broken anything. Again, this is very flexible. You can set these steps up however you want. In general, the structure of these is going to be fairly similar to this as a good starting point. You're going to want to build, you're going to deploy, you're going to test. You can do other stuff like code linting and checking for known vulnerabilities by doing security scanning your dependencies. There's a lot of stuff you can bolt onto this, but this is kind of the core of CI/CD: build, deploy, test. With those three steps, like, you're going to get yourself 90% of the way there, and you're going to save your developers a lot of time and effort from having to do those steps manually. Now, there's some other benefits to doing that in a pipeline, in a file like this, is that this file is shareable. So once I get this pipeline built and tested and working, and I'm successfully deploying my application with it, if another developer wants to also author a Lambda using C++, they could come in and copy this file, copy my deployment script, and they'd be in business. They'd already have the same pipeline structure. They would understand what repository secrets they would need, and they would be able to very quickly build out a pipeline that's equally as effective. Now, this means you can enforce best practices across your teams by sharing these files. You need to design and build one great pipeline that kind of works properly, and then everybody else can copy that pipeline and just modify it slightly for their own needs. So as an example, if we weren't doing C++ development, say we were doing Java development, the deployment script here would be different. It wouldn't, or sorry, the deployment script might be the same, but the build step would be different. You would have maybe different steps in here to invoke a Java build tool. And your image that you used to do the Java building steps would also be different. So with a little bit of mix and match of your Docker image and maybe your build step, you could reuse a fair bit of this pipeline. Now I want to move over here and take a look at our Docker file real quick. We're not going to dive into this too deeply, but this basically shows we start with Amazon Linux 2, and then we just install a bunch of development tools that we need. So we're going to install DevTools, libcurl, CMake, Git, and a few other things. We're also going to install the AWS Lambda CPP runtime, and we're going to install the AWS CLI. These things are necessary for doing the deployment. If you had a different set of tools that were required, you'd author a different Docker image and you would install different tools and you'd be good to go. So it's a very flexible way of doing things. Now, the other thing I want to take a look at really quickly is our deployment script. This is not Bitbucket specific. This is just a bash shell script that invokes some AWS CLI stuff. We basically create a role. We check to see if the role exists. If the role doesn't exist, then we're going to create it. If it does exist, then we don't have to do anything. So it just verifies that the role is there. Then we're going to check to see if our function exists. If the function already exists, we're going to do an update. If the function doesn't exist, we're going to create a brand new function from scratch. So you can build kind of branching logic by having a deployment script that does kind of the steps that you want to do. And then we can invoke that script from Bitbucket Pipelines simply by executing it like you would off the command line. So it functions the exact same way, except that this will execute inside an instance that has all the tools that you've installed from in your Docker image. Now, if we want to run this, let's make a change to source. So we're going to vim source main, and let's change cake to waffles. All right, so we've successfully pushed our branch to our repository. And if we take a look at pipelines here, you can see that change cake to waffles, we are starting to execute our pipeline. So if we click in here, we're noticing that we have the same steps. We're building the app, we're deploying to test, we're running the tests and test, we're deploying to staging, and we're running the tests and staging. So I'm going to jump back over to the terminal just to take a look at that and show you that it's the same set of steps. So again, we build, we deploy to test, we run tests and test, we deploy staging, and we run tests and staging. Now, this is going to take a couple minutes to run, but once this is done, we'll have successfully deployed to 2 environments and we'll have run tests in 2 environments. Now, if you click in here, you can see all of the steps that were run and you can take a look at the output of those steps. This is very helpful for debugging. So if you want to figure out what a step did and how it succeeded or how it failed, you can go into here and take a look at those. We just ran our tests. So again, we've exported our access key, we've exported our secret access key, we've exported that the AWS default region is CA Central 1, and we've invoked our function. And we can see that the function returned successfully. So we got a status code 200. And one of the things I did was I catted the output file this function invocation creates, and we can see that it displayed waffles. So we have successfully deployed our change. Now, I want to show you where to set up these repository secrets. So under repository settings, we scroll down, we can go to the pipeline section again. And under the pipeline section, there's repository variables. And under repository variables, you can set up as many secrets as you want. So to add one of these, you would give it a name. You would add it. You can make it secure or not. And if we add a secret, it is now available. This can be referenced now in your Bitbucket pipeline files with the $ curly brace syntax, which we see here. And you can delete these if you need to. So now let's go back and take a look at our pipeline and see if it's finished. All right, cool. So we've successfully run our feature branch pipeline, which has done 2 deployments, 2 tests and to staging. Now that we're done deploying to staging, we can make a choice to cut a pull request and deploy to production. So to do that, we're going to click into pull requests. We're going to click create pull request. Add a description. Create pull request. Approve and merge. Once this is done merging, we can jump over to pipelines. And we should see that we've got another pipeline kicked off. So we've seen merge in foo here. We drill into this. We now see a different structure. We're building the app, we're deploying to production, and we're running tests in production. So I'm going to jump back over to that Bitbucket pipeline file again. And again, branches, we merged into mainline, which kicked off build, deploy to production, and test in production. So you can set these up in any way you kind of desire. If you want to have many more regions, that's very possible. If you want to have fancy rules about which pipelines execute in which branches, it's very possible. You have a lot of fine-grained control over the execution criteria of these pipelines. We're not going to go into any details about that here. This is meant to be a bit of an introduction. But basically, that's the cycle developers would go with. They create a repository, they enable pipelines, they author a Bitbucket pipeline.yaml file, which completes the steps that they want. And when they push, the pipeline will execute based on whatever branch it was in. And again, the value proposition is that it saves you a lot of time versus manual deployment. It's a lot safer than manual deployment. Trying to do all of that stuff manually over and over in a repeatable way leads to human error. It can be dangerous. People make mistakes. But once that pipeline is built and created correctly, it's going to execute the deployment steps correctly every time. The other thing you get is you can share these files back and forth. So if you want to give every developer access to this Bitbucket pipeline file, they can copy it, and it shows them how to grab whatever Docker image out of your Docker repository they need to use. It shows them how to build a build step. It shows them how to do a deployment step, shows them how to run a test step, and you can show them how to set up your pipelines in particular. So this means that if you have 10 pieces of software that have to go to your regions, you can set all of the pipelines up to be very similar, to have the same steps, to do code linting, to run security scans, to run integration tests, to run unit tests, to run end-to-end system tests. And you can have them all do them in the same way. So you get a lot of reliability out of this, and it lets you have your developers focus on building stuff rather than mucking around with deployments. Let's take a look and see if this is finished, and it has. So again, if we take a look at the cat of the output of that file, we have now changed this to waffles, and we successfully deployed to production. We can take a look at, once this loads, deployment script. So in here, we ran our creator update lambda, we called get role, we called get function. The function wasn't found because we hadn't, or the function was found because we already deployed to it. We're just deploying an update. So we can see that we are calling the update version of it, and you get your output. So it lets you really diagnose what happened during your pipeline execution.